Okay, good evening, and thank you for joining. Time is ticking. This is the CAGNY's third year of our environmental campaign. It always runs to coincide with COP28 or COP generally, as it's important that we bring to the attention of everybody the ramifications of aviation, not just on noise or emissions, but on the planet and the impact flying is having. We have had an array of speakers over the years, and we're very fortunate that people are willing to give their time freely to us to speak. It will last an hour this evening. As I say, this evening is talk number 2. Tomorrow evening we have talk number 3. That's with Steve Clark of the Bristol Group, who's just launched a new campaign of no airport expansion. And he took his case to the High Court and was party to questioning the government's policy on Jet Zero. So the talk tomorrow evening will be an interview with our very own CAGNY's Lisa Morris. So it will be a chatty tomorrow evening if you want to join us. Now, getting back to this evening, we are very welcoming of Tony Whitbread, who's giving his time this evening. The title of the talk is Climate Change, How We Got Here and Where We Might Be Going. Now, Tony is president of Sussex Wildlife Trust, and he's an independent ecologist. So what I'm going to do now is hand over to Tony. Bear with us whilst I unpin myself and pin Tony, as you see, Tony. And thank you.
Okay, shall I take it from here?
Please do.
Thanks very much indeed, and thanks for inviting me along here this evening. What I'm planning to do today is to talk a little bit kind of generally about climate change. So I won't be talking very much about aviation, but I think actually grasping the scale and the urgency of the climate emergency, I think is, it really underpins all the work that you're doing. So if you give me a minute, I shall just open my screen up. If I can get the right thing up. Give me a second. There we go. Can you all see that? Excellent. Okay, climate change, how we got here and where we might be going is the kind of vague title I've given it. What I like to do with these things is actually start with a bit of context. Where should we actually start? And I think it's helpful to actually go back to basic principles and work out, well, how does the energy work that we're talking about here? And it all starts with the sun. In as much as it already matters in our local part of the universe. It starts with the sun. Energy effectively is created by the sun. There's the sun and there's the earth at the same scale. The sun's quite big, isn't it? It really is quite enormous. The sun creates energy. It destroys matter, and from matter it creates energy. And those of you who know your Einstein, E equals mc squared. If you totally destroy an amount of matter, it's the mass of that matter times the speed of light squared is the energy that's created. And the sun destroys about 4 tons of matter every second, creating it, turning it entirely into energy. It's been doing that for 4 billion years. How much energy is actually produced by the sun? That much. Well, that's a lot. I mean, I find it difficult to imagine how much energy that is, but a few sums later, and it's actually that many boiling kettles. Well, that's interesting, but it's a good place to start. So that's the energy that's emanating from the sun. That's what's actually pouring out of the sun all the time. Think about how much is hitting the earth. Well, it's 175,000 million watts. Again, quite a lot, but it's difficult to picture. Bring that right down to what this means. And actually, it's roughly a boiling kettle every square meter or so, on average, over the whole of the earth throughout the year. So it's a very averaged figure. But this is kind of useful because it gives you the idea of the amount of energy that's hitting the earth. That's the energy that goes into virtually every energy form we know. It goes into life. It's actually the battery that charges up life and makes life possible on this planet. Okay, so that's the starting point. That's the way energy flows. You know the phrase renewable energy. That's actually an accepted misuse. There's no such thing as renewable energy. Energy is a flow. It starts with the sun. It flows flows out from the sun, but for our purposes, it flows towards the earth, and then it dissipates as entropy. So this will come up later. in what this actually means in practice. So energy is a flow. It's not renewable. It flows from the sun, out from the sun, and the bit of it that strikes the earth is then dissipated as entropy, or in other words, heat. Okay, so we know how climate change works. The sun's rays hit the earth, and the same amount should be reflected as strikes the earth. Then it stays in equilibrium. Okay, I think we understand that. You know, if the same amount is hitting the earth and is being reflected, then actually we stay in equilibrium. We stay roughly at the same temperature. But as we all know, a thin veil of carbon dioxide actually reduces the amount that reflects away. So therefore, the Earth's temperature heats up a little bit more until it comes to another equilibrium. So carbon dioxide, a small amount of carbon dioxide, prevents some of that heat from escaping. We all know about this, the glasshouse effect, the greenhouse effect. How much? So how much is that? How much energy is actually prevented from going out into space? Well, actually, it's been known for a long time. I think the first experiments were done in about 1860 or something. It's up to these days, it's under 3 watts per square meter. So under 3 watts is the amount of surplus energy that's absorbed by the Earth. Well, that's a tiny amount, isn't it? That's barely enough to light one small LED light bulb, is the surplus energy that hits the Earth per square meter. However, there are a lot of square meters, aren't there? If you add that up over the whole of the Earth, then actually the amount of surplus energy that's being absorbed by the Earth because of a thin veil of carbon dioxide is the equivalent of 25 billion Hiroshima bombs over the last 50 years. I'll just leave that up there for you to think about. 25 billion Hiroshima bombs is the surplus energy that's being absorbed by the Earth. Most of it, 96%, going into the oceans. So there's surplus energy which is constantly pouring into the Earth because of the surplus carbon dioxide that's in our atmosphere. Okay, let's remind ourselves about the carbon cycle, because again, this is useful background. I'm sure you all know this. On the one side, we have carbon sequestration, which is the process of photosynthesis whereby green plants, using the energy of the sun, absorbs carbon dioxide and water and combines that to form carbohydrates, which is the basis of virtually all life on Earth. On the other side, we have respiration, decomposition. You can see the dead elephant at the bottom there, that represents decomposition. You have respiration and decomposition, which emits carbon dioxide. Now the numbers there, 770 gigatons of carbon dioxide, actually the numbers don't matter. What matters is that it's in balance. Normally, the amount that's sequestered and the amount that's emitted is roughly in balance, so you have an equilibrium. Of course, what we actually know what's happening is because of fossil fuels and deforestation, we mustn't forget land use as well, there's a net surplus of 40 billion tonnes per year being emitted. So that's over and above the natural cycle. So this again is worth bearing in mind. 40 billion tonnes of carbon dioxide over and above what can be absorbed is being emitted year after year, and it stays in the atmosphere for a very long time. Okay. At this point, I don't think we should spend long talking about climate change denial, because actually we should have moved on from this. But I thought I'd just put this in at the moment, because you still do get some of these flat earthers piping in every now and then with things that are routinely debunked. But actually, there's various stages of denial, and there's a thing here I call the staircase of denial, and you'll still see this trotted out time and time again. Here we are, a bit of a graph of the temperature anomaly. No increase at all over that period. Here we are, another period. Again, no increase at all. You can see, even if anything, there's a slight decline. You know, again, next period, oh, clearly that's a declining period. Surely we should be told the truth about the way the temperature is actually going down in that period. Next period, again, no growth. Time after that, again, no increase in temperature. Again, no increase in temperature. And the last one here, again, no. You know what's actually happening here? This is a very common trick, which is still used over and over again, cherry picking points on the graph in order to show something. We can very clearly see what's happening there. It's that. But you'll still see, trotted out time and time again, people showing cherry picking periods of warming to show that something's not actually happening when it's very clear it is happening. You can also use the other way around as well, so we should be careful of exaggeration too. Okay, the other thing that people say is, well, isn't this all just natural variation? The climate's always warmed, the climate's always gone up and down. Which, you know, It's like saying these things which are true but unhelpful. Yes, the climate has all varied, and there has been a lot of natural variation. But I think if a scientist was told about climate change, if he hadn't heard about it before, after about 2 seconds, he would say, is this climate? Is this variation? Is this natural variation? So yes, it has been thought of. And as an example, here's looking at just solar activity. People say, oh, it's all the sun. The yellow line is solar activity. If anything, it's declined, and it's not related to the way temperature has gone up. In fact, scientists regularly correct the carbon dioxide and the temperature values according to the sun's activity at the time. So of course, it's not solar activity, but it's not other things either. It's not volcanoes, it's not the wobble of the earth, it's not the way the earth goes around the sun, it's not stardust, and stardust has been used as well. No, this is very well accepted. We are causing climate change. So where do we get this information from? Again, you probably all know this. We get it from the Intergovernmental Panel on Climate Change. Sometimes this is presented as a small group of a few scientists who are kind of going against proper scientists. Well, that's very far from the truth, isn't it? It was formed in 1988 by the World Meteorological Office and the United Nations Environment Programme, 195 member states. It's supposed to inform governments so they can make decisions. It involves thousands, perhaps tens of thousands of scientists around the world who often volunteer their time. It's the most scrutinised scientific body in the world, and there is the highest degree of scientific consensus for almost anything of this complexity. So there's huge amounts of scientific consensus. You may have heard that, I think a few years ago, there was 97% consensus from scientists on climate change and the cause of climate change. Obviously, it's not a democratic exercise. Maybe the 3% are right. Well, they've been closely examined, and it's found that those 3% had basic errors in their science, and when corrected, they fall into line as well. Massive degree of scientific consensus. And I just thought I'd show you this picture because sometimes it's given the impression that there's a few scientists in White Coast working in laboratories with models or something, and there's lots of other scientists saying other things. This is one example. This is the number of observing stations for ocean temperatures alone, all over the world, thousands of them. There is masses of data being collected for informing this huge scientific consensus. So it's just one example. And it's not just the IPCC. Here's a diagram. It's from 1982, so it's a little bit scrappy. I hope you excuse that. You can see very accurately predicting where we were going to be. Very accurately showing that by about now, we would be at, what's that? I don't know, about 1.5 degrees. Well, by 2030, 1.5 degrees was predicted. And by about 2050, 2 degrees is predicted. Okay, so where's that from? That's from Exxon. ExxonMobil did know. This was an internal document. They had done all the research. They'd worked out exactly what was going to happen and had predicted it very accurately. We all know what then happened. It was hushed up and covered over. So it's not just the IPCC, even the oil industry itself has known all about this for decades. And there we get the global temperatures that you're probably all very familiar with, the way that temperatures have increased over the years. Now, I like to show this one because this shows carbon dioxide increase. There it is going up and up and up in a very steady cycle. It kind of wobbles up and down on a yearly cycle because of the way the Earth, it's the productivity of the Earth pointing towards the sun. It varies from north and southern hemisphere throughout the year. So that's why you get this sawtooth diagram. But this is the increase in carbon dioxide concentrations year on year on year over the last, 60 years. And that's in spite of all the kind of conferences, protocols, accords, agreements, conferences, testimonies. You can look at that and you can't really see the slightest dent in spite of all these conventions. The UN Convention, Climate Change Convention, 1992 is shown there in red, as that was the time. That was the time we said, we are going to cure this. The Framework Convention on Climate Change, the starting point for all the conference and part of parties, the COPs, we're now at number 28. That's when all the COPs started. That was when we were going to do something about it. Look what happened. Another way of looking at this, that's thought of as being the safe limit for carbon dioxide concentrations. Okay, 350 parts per million. Above that, and we're really in difficult territory. That happened in about 1990. So the 1992 conference was actually very timely. That was the point at which we should have done something. Well, we know where we are now. We're up here, 420 parts per million. And in the pre-industrial period, we were down there at 280 parts per million. So that shows just how serious this is. Where does this CO2 come from? We all know, don't we? Oil, coal, gas, fossil fuels that have actually, these fuels resulted from sunlight that hit the earth millions of years ago and formed oil, coal and gas. That's why it's called fossil fuel. They're fossilized fuel. In fact, you could say oil, coal and gas are not an energy source, they're an energy storage device. The actual energy was still the sun. But you can see the proportions there. That's important. We're saying a lot about renewables, a lot about nuclear, a lot about hydro, as though it's kind of taking over the world. It is covering a lot of the growth, but when you look at the total amount of energy that's consumed, it's still vastly fossil fuels. This I find a staggering statistic. Remember that period, 1992? We were going to solve climate change then. That was when the Conference of Parties started. What's actually happened? We have emitted as much CO2 since 1992 as we have in the whole of human existence before 1992. Again, think about that for a while. This is how exponential growth works. Now, I ran the figures back a little bit. Yes, I'm my great age, I know, but more than 75% of all the CO2 ever emitted has been emitted in my lifetime. I'd like to think about those two figures. How long can this go on? How long can we carry on doubling? If we carried on the way we are now, within the next 30 years, we will do the same again, and again, emit more carbon dioxide than in the entire history of the human race to this period. Okay, how bad is it? Well, you've seen all the figures. I could put all sorts of things up here. Record temperatures all over the world. The Arctic and the Antarctic are supposed to be the canaries in the cave. That's increasing at 4 times the global average. Record temperatures in places like Death Valley, the appropriately named Death Valley. Ice caps melting all over the place. 28 trillion tons of ice lost in the last 30 years. I can't really picture that. That sounds a lot. We all know about record wildfires. Canada suffered most this year, I think. Glaciers melting, right, left and centre as well, threatening long-term water resources for billions of people. So we know it's pretty bad. The IPCC presented this global warming document back in 2018, looking at the difference between 1.5 and 2 degrees. We're now at about 1.2 degrees. And basically they came to the conclusion 1.5 is the limit. If we go above that, we're in for serious trouble. At the moment, we're at roughly 1.1, 1.2 degrees above pre-industrial levels. That's likely to persist for millennia, no matter what we do. Okay? There are risks to natural and human systems at 1.5 degrees. These are high risks. In fact, we're already feeling them. But it's far, far worse at 2 degrees. 1.5 seems to be a line in the sand, and we're almost certainly going to shoot through that very soon. The trajectory is actually 3 or 4 degrees of warming, probably this century. That's not survivable. The human civilization will not survive that degree of warming. And even at the moment, we all know, of course, there are already widespread extreme events. I quite like this diagram because it sums up that. Where we are. It's 800,000 years. The left-hand end is compressed a bit. The right-hand end is the Holocene, which is the recent period since about 12,000 years ago. The pattern, the shape of this is very important. If we look back before 12,000 years ago, the temperature went up and down all over the place. This roughly marks the period of our genus, our family of species, Homo, 800,000 years. For the last 200,000 years is the history of our species, Homo sapiens. 200,000 years ago, we were just as clever as we are now, wasn't any different. And yet we didn't have any agriculture and we didn't form civilization until 12,000 years ago. Why is that? Well, the reason was because the climate was not appropriate. We have this myth that we've got very clever recently, and that's all because we got so clever. That's just a conceit. In fact, the temperature, the climate rather, has settled down into a very predictable period throughout the Holocene, the last 12,000 years, where seasons were predictable. The global temperatures around the world were reasonably predictable. We knew how to develop agriculture as a result, and therefore agriculture was developed and civilization and a huge increase in human population. We are bringing that period to an end. You can see those dots. By the way, there's a health warning on the right here. This is in degrees Fahrenheit. That's why the figures look so big, but it's still the same pattern. We are bringing the Holocene to an end, which is why sometimes it's called the Anthropocene. We don't know what's going to happen. Maybe what we're going to be creating now is something like in the past where agriculture won't be possible. I think you can guess what that means. We've heard about El Nino. I thought I'd show this graph here, this diagram here. Look at that kind of streak of red coming out from South America going across the Pacific. Those 25 billion Hiroshima bombs are being disturbed every now and then in the El Nino period. This is when the heat that's been locked up in the seas comes to the surface for a period. It's a natural cycle, happens all the time, but we are now entering an El Nino period. The last few years, believe it or not, we're in a cooling phase. So all the records that were being broken last year when we're in a period where the temperature was supposed to be lower. We are now entering an El Nino period, and that's why 2023 has been the hottest year yet. The odds are 2024 will be hotter. Lots of graphs you could show. Here's the sea surface temperature anomaly in the North Atlantic, the red line. Doesn't really need much description, does it? That's way above not just averages, but all the other temperatures that have been recorded in the North Atlantic. I quite like this diagram as well. There's some recent information here. See the slightly darker shade in the middle of that, and the red line is the trajectory. If you use the data up until 2015, you can see that 1.5 degrees centigrade is likely to have been, as a trend, not as a peak, as a kind of average trend, 1.5 centigrade was likely to be exceeded in 2045. Bit of an emergency. But if you add in what's happened since 2015 as well, then the trend line goes up. And actually that 1.5 degree limit is likely to be broken by 2034. And that's not assuming that the temperatures in the 2024 onwards are going to increase. That's using the existing trend line. A bit of a worry. The other thing I think is quite interesting to point out is what's tending to happen when it comes to air circulation. The poles are heating more than the rest of the planet. And what that does is it makes the jet stream, which should be holding the colder air in the Arctic, it makes it weak. So you get wobbles. And this is what we see, wobbles in the jet stream, allowing cold air to move south and warm air to move north. Ironically, it could be because this jet stream is weakened because of the increasing strength of Arctic air, we could actually get colder air coming south rather than actually getting warmer. So we could get all sorts of weird things happening roughly at our latitude, where occasionally we get really, really hot periods and occasionally we get really, really cold periods. Watch the weather forecast these days. Look at what's happening to the jet stream. It's wobbling a lot more than it ever used to. Okay, so what's our response? What should we do about this? Well, I'll put this into two broad categories. Mitigation, stopping the damage basically, and adapting to whatever damage we are inflicting and trying to restore nature. So mitigation first. What about mitigation? What do we need to do when it comes to our emissions? Well, I think we all know about this, don't we? We know what we should be doing. We need to be, on an emergency basis, reducing our carbon dioxide emissions. These are the so-called mitigation curves, the speed that we should be reducing our carbon dioxide emissions in order to keep to within 1.5 degrees centigrade. Look at that black line on the left-hand side. That's historical emissions. And look at the kind of curving black line on the right-hand side. That's how fast we're going to have to reduce our emissions. I've taken away some of these things and just kind of interpreted it from my perspective. I think in the past, we had a chance of a smooth transition. From about, say, 1992, when we said we'd do something onwards, we could have had a smooth transition towards a different sort of society. I think the chance of a smooth, slow transition has now gone. If we'd have started to head towards net zero in 1990, we wouldn't have had to get there till about 2100 or afterwards. But because we left it so late, it's becoming far more urgent. We are now in a time where disruption is the only way we are going to go forward. We need changes which are of such a scale that it will disrupt what went before. If we don't achieve that, then we're looking at catastrophic levels of change in order to try and conserve the concept of 1.5 degrees centigrade. And this is where we actually are. This is what's likely to be happening in the most optimistic projections. The NDCs, the nationally determined contributions, what governments said they would do in order to, the commitments they made to reduce carbon dioxide emissions. So that's not what's actually happening. That's what governments said they would do. Very different things. Even there, you can see we're miles away from where we should be. And actually, even that is optimistic to what's actually happened. I think where we are, I talked about climate denial. I just put that in earlier in order to give some context, because I think we're in a state of, we could be in a case of mitigation denial. Everybody that matters now accepts climate change is happening. But I think there is now a kind of mitigation denial. Yes, it's happening, but it's not that serious. It's not that bad. We can't really do much about it. We can have a, what did the Prime Minister say? We could have a moderate response, you know, a proportionate response to this perhaps minor problem that we're facing. That's mitigation denial. It's almost as bad as climate change denial itself. We're not alive to the scale of change that's actually needed. And I quite like this diagram as well. Look at that on the left there, most of the left-hand bit. 78% of the energy we get still comes from fossil fuels. Only the last little bit at the top there comes from anything remotely non-fossil. And this is proportionally as well. This doesn't allow for growth. In practice, renewables are barely keeping track of the increasing growth in demand for energy, let alone replacing fossil fuels. So it kind of doesn't work. That's why somebody's written in there, this is where magic goes. We need, you know, the scale of change looks like, you know, magic proportions in order to get our energy use down or increase the renewables to actually get us back on track to a livable future. It's very difficult to look at these diagrams and not come to the conclusion that as well as renewables, we're going to have a massive decline in the amount of energy we actually use. You could say renewables are a bit of a divergence. Certainly by themselves they are. We are needing an energy descent plan of significant proportions. All the things that take masses of energy are really up for grabs. And I think you can guess one of the sectors I'm thinking about when I'm saying that. Okay, we need to think about disruptive levels of change. Not slow transmission, not baby steps, not we'll maybe get round to it next year, not maybe in 2050 or whenever the date is chosen. Anything that's going to work is going to be disruptive. Kevin Anderson, one of our top climate scientists, said there are no more non-radical futures left. The most radical future will probably be if we try to do nothing about it. So I want to introduce kind of two different organisations here, at different ends of the perspective of the spectrum. At one end is a group called Rethink X. Another is a group called How to Enjoy the End of the World. Now, they say different things from the same sort of perspective. Rethink X, and I can't spend long on this, I really encourage you to kind of Google this afterwards and look at both of these because they come up with some really interesting concepts. Let's look at Rethink X first. This is a think tank made from some mega intellects who present a very, very positive picture. They say we're on the cusp of the fastest, deepest, most consequential transformation ever in human history. They see disruptive change not happening in just one place, but in 5 of our biggest sectors. I think they mentioned food, energy, information, transport, things like that. Technology is changing so fast that the way this is going to change in the future is out of control. It will be disruptive and it will replace everything that's taken place before. And it'll be, by and large, extremely beneficial. We will be moving away from these old technologies. That's one of their thoughts, which is interesting. Technologies will converge to completely disrupt the sectors that we're thinking of that underpin the global economy. Transport, the move to electric cars, they see as disruptive. Food, they see the move towards precision fermentation and artificial meat as disruptive. These sorts of things completely changing the way that we actually get some of our most important things. They present this sort of diagram. I'm going to criticize this to some extent, but I think there is truth in this. You know, you look back in the past of humanity, we've been through some major changes. From the age of survival, when we were hunter-gatherers, to various stages of expanding our agricultural approach, lastly to an industrial approach. They say we're now at another one of those inflection changes, where all of these disruptions are going to mean something completely different in the future. Now, this is exciting and quite encouraging. They present it as a breakthrough. The worry I have is the way this is written looks like another chance for huge expansion and breaking through our boundaries. I don't think that's going to be at all possible. There's a phrase used by some people which I think is relevant here, and that's the idea of being energy blind. I heard a concept the other day from a group of economists that said in future we're going to discover a magic new form of energy, which means that every one of us is going to be able to use 1,000 times more energy, which means we can have much more, we'll break through. We'll have this unlimited energy, and we'll be able to do whatever we want, and it'll be a fantastic new world like Star Trek or something. I don't know. The reason I say that's energy blind, let's forget about carbon dioxide. Let's go back to the sun and the way it produces energy. I said it's an energy flow which dissipates eventually as heat. Now, if you had an unlimited amount of energy, if you had 1,000 times more energy, it still eventually dissipates as heat. Forget the greenhouse effect. It will all dissipate as heat. If everyone on this planet was using 1,000 times as much energy, all that energy would have to dissipate. And that would heat up the atmosphere, not just 1 or 2 degrees centigrade. I think somebody calculated it would heat up the atmosphere about 40 degrees. So this idea that we can break through and continue our energy growth is cloud cuckoo land. So I think what Rethink X are saying here is far more sophisticated than just a way of continuing our kind of exponential growth. What do I mean by disruption? I think we do have examples, in fact, far more examples than we realize. And I think this is encouraging when we think about how disruption actually works. We think change happens gradually. We think it takes forever for change to happen on a kind of linear way. That's not the case. Let's look at an example. The year 1900 in New York City. The question then, where's the car? And there it is in the middle there, a little car, chugging its way along there, in a street completely dominated by horses. Just 13 years later, where's the horse? In 13 years, the whole automotive industry, the whole way of getting around had completely changed. Nobody in 1900 was saying that there was going to be this big change. If cars were going to do anything, it was going to be a small change, blah, blah, blah. But it was complete disruption. With that disruption came complete disruption for the way cities functioned, the way we traveled around generally. So this is the level of disruptive change. Things you think are going to be slow actually accelerate very, very quickly, and then suddenly there's a type change. Now, maybe it's a bad example because maybe that's led to some of the problems we've got now, but it gives you the idea of how disruptive change can actually happen and gives you maybe cause for some hope. The other end of the spectrum I want to encourage you to kind of Google afterwards is somebody called, I've forgotten his name, Tim Smith. Tim Smith? Sid Smith, an American professor who did a series of videos called How to Enjoy the End of the World. And his basic premise is that there's an inevitability of a fundamental change because of the way energy functions. There will be a great simplification. Because of those graphs I showed you earlier, they will not carry on going up. We will not double the amount of carbon dioxide emitted again. There's going to be a fundamental shift. And he calls that a great simplification. The word collapse is a little bit emotive. I think somebody else has actually said, there will be the end of civilization as we know it, but that doesn't mean the end of civilization. Something more interesting is likely to follow. So this series of videos, I encourage you to look at. He comes to almost the opposite of conclusion of Rethink X, but I feel there's something in the middle of these two things. Disruptive change, which gets onto a completely new track, which is a far more simple society than what we have at the moment. It's worth looking at that sort of thing. Anyway, moving on. That's just a little bit of a taste of where I think we might be going when we think about the repercussions, the speed that we have to succeed in mitigation. Let's move on to adaptation and restoration, and in particular, natural climate solutions. Yes, I used to work for the Sussex Wildlife Trust, so obviously I'm interested in natural climate solutions. And we can think of habitats in two ways in terms of carbon. Natural habitats, both store carbon, they hold large amounts of carbon, and they also remove carbon from the atmosphere. That's how photosynthesis works. That's how it's worked for 2 billion years. Carbon dioxide from the atmosphere is absorbed by plants to make plant material. So it's worth thinking about these two things together. Habitats both store carbon and they remove carbon. One's a store, one's a stock, the other's a flow. And we look at some of our habitats. This is interesting because it may surprise you. If you look at the amount of carbon stored in vegetation and the amount of carbon stored in soil, the vast majority of the carbon in our habitats is stored in the soil. That's the orange bit. It's only the blue bit, which is in the actual vegetation itself. Look at the one on forest tree cover there. If you walk into a forest, you walk into a wood, you look around there, all that standing carbon, all those trees are made basically of carbon. You look at that, and then you realize 3 times as much carbon is in the soil that you're walking on rather than the trees that you're walking under. Other habitats, it's even more so. Peatland, vast stocks of carbon are stored in peat, with very, very little actually in the vegetation on the surface. So this gives you an impression of the vast amount of carbon that's stored in our habitats and how vital it is that we keep them that stored in our habitats. Therefore, we need an environment that is able to adapt to change, whatever that change, the change that's forced upon it. Okay, and how do you do that? We don't know what change is going to be. Think of those pictures of the jet stream. We don't even know whether it's going to be hot or cold some years. So how do you do that? Well, the principles are actually pretty simple. First of all, we must look after what we've already got, looking after our existing habitats. We mustn't damage it anymore. There's vast amounts of damage have been done to the natural world. I think 68 to 70% loss of vertebrate populations since the 1970s. We can't afford to lose any more. Next, we need ecologically varied landscape. Rewilding may come in here, ecological networks and so on. Ecologically varied landscape, so things can move and adapt within their existing landscape. But also we need ecological networks. Animals, plants and so on are going to need to move over large distances. They're going to need to be able to function over large spaces. They can't survive in small cut-off blocks, so we need ecological networks. So 4 principles, which are actually pretty familiar principles as the tenets of nature conservation anyway. So we know roughly what to do. Think about Horsham District that I'm sitting in the middle of. We need to change a Horsham District which looks a bit like this, the green bits and the nice bits. Yeah, it's quite a nice district, but those bits are quite isolated. There's now a nature recovery network map formed by the District Council, which shows how we can start to link up these things and create more varied landscapes that are interlinked, connected. We need to do this sort of thing. Landowners themselves are coming together completely independently of non-government organisations and councils and developing their own ecological networks. Some of you will have heard about the Wheel to Waves project, which has been formed by landowners, local community groups, I hope with some help from the Wildlife Trust and others. So this sort of thing is happening, but not just on land, also in the sea. You know, out of sight, out of mind, we have lost vast amounts of our kelp forest in the just off the coast of Worthing. This was 1980. Since 1980, we've lost about 96% of the kelp off the coast of Sussex, which locks up more carbon dioxide than equivalent area of forest on land. Fortunately, it does come back. And now because of a trawling ban that's been conducted across the whole area, just for the last 2 or 3 years, we're starting to see the signs of an ecosystem recovery. So you can actually give nature time, give it the space, and it can come back. So what I want to end with, I suppose, is a vision of the future. And just think about, we need to get our emissions down as a matter of urgency. That's going to point towards a society which will be fundamentally different to the one we're in now. I wouldn't say it's going to be worse. I would suspect it's going to be better. But when it comes to our landscape, look at what we can do. Here's the green and pleasant land, but actually all those habitats are rather isolated. If you look on the left-hand side there, you could think about maybe some rewilded areas. Look on the horizon, some of the upland areas could perhaps have been rewilded as well. You could perhaps think about some corridors connecting up some of these areas so things can move, things can adapt. Changing climate, animals can adapt to that. Plants, habitats can move and adapt to a changing climate given the chance. Even more so if we look in between those gaps and think about what sorts of agriculture we can encourage, which allow plants and animals, habitats to coexist within our agricultural landscape, not just be something that happens somewhere else. We think about crossing those roads as well, allowing for interconnectivity across our landscape. And also we can think about, well, what do we do on our river valleys, which have been very scoured over the years, and flood defences have ironically probably caused more flooding and also wiped out quite a lot of our wildlife. Can we re-wriggle some of our meanders in our rivers and actually encourage them to, first of all, be better adapted, but also lock up carbon as well? So I think I'm ending now by saying we won't solve the climate crisis without nature. It is absolutely vital that on the other side of the coin about mitigation, we must restore nature, because we won't solve the climate crisis without nature. However, this is a very big but as well. Sometimes I've heard people saying, oh, it'll all be fine, we just need to plant a few more trees and that'll compensate for all the carbon dioxide that industry creates. No, that's not the case. Nature restoration alone won't save us. It's absolutely essential that as well as restoring nature, we must get our carbon dioxide emissions down to net zero as soon as possible. I don't like the phrase net zero because I think it gives too much of a cop-out clause. We're leaving things so late that not only must we do this as a matter of urgency, but once we've reached net zero, we're going to have to carry on going down so we absorb more carbon dioxide than we're emitting. In fact, most of the scenarios that you'll look at assume that's going to be the case. And I think with that, I shall say, just to do a quick summary, it's too late to stop climate change. That should be past tense, climate changed, because it's already happened. It's too late to stop it. We need to stop emissions. That's the starting point. We need to take carbon dioxide out of the atmosphere, preferably by using nature solutions. So we must be on the cusp of a huge technological and societal change. Slight hesitation there. I don't like the idea of techno-fix alone. People thinking there's going to be magical technical solutions to these problems. Technology isn't the solution in itself. It must be matched with societal change as well. So we must be on a cusp of technological and societal change. We need to build resilient landscapes, as I've described, and nature must be part of the climate solution. We also need to build resilient societies. I haven't talked about this today, but it's probably even more important that societies need to be in a position to be able to respond to the changes that are inevitably coming. We do have a better nature. Thank you very much. With that, I think I shall end and stop sharing my screen. I dare say we got time for a few questions, haven't we, Sally?
We have indeed. That was amazing. Thank you so much. Right. Okay, let me just remove the pin there. Oh, is there anybody who would like to ask a question? If you could raise your computer hand, that would be helpful.
I guess a lot of this is probably familiar to everybody, isn't it? But it'd be good if we had a little bit of a chat.
Well, if I can just perhaps say that aviation is already suffering the effects of the global warming. In the record temperatures that they found at their holiday destinations is actually causing these holiday destinations an issue, but it's also the jet stream. It's actually affecting the aircraft flying. So something that is actually damaging the planet. And just to give you an idea, that the second runway that Gatwick are proposing at the moment, that would add between 0.5 to 1.5 million tons of extra carbon a year just from that second runway. And we might have all seen that Virgin flew an aircraft just before COP28 started on sustainable aviation fuel, SAF. But as Tony rightly shows, you know, do we want to have nature on the ground, or do we want to have mass crops growing aviation fuel? You know, the resources for sustainable aviation fuel is just not there. So we really are in a tipping point where we really do need government to be making sensible decisions, especially when it comes to aviation, because it is one of the biggest polluters that the planet faces. And as Tony rightly says, nature can't do it all. We have to make some sensible decisions here. So anybody like to ask a question? Because I still can't see any hands, and I have just...
Which is just on that point, actually, yeah, it's cloud cuckoo land, isn't it? It was a pure PR stunt to actually think that X chip fat oil is going to fuel our aeroplanes is just ludicrous. I think I heard somewhere that if just the British flights, if we actually made enough sustainable aviation fuel, it would take all our agricultural land. I'm surprised it's that little, actually. I should imagine it's far more. In order to have aeroplanes, even at the current level, we're planning for growth, then agriculture will have to make fuel for aeroplanes, not feed people.
And we've also got the added pressure, obviously, of them trying to build houses on the green land of Sussex alone, but on basically any land they possibly can to build homes. So we are a small island. And I asked the question actually at Gatwick Airport yesterday: did Virgin fly back to America on chip fat oil or whatever? And they sort of went, no, it was just a PR stunt before COP. And so they actually admitted that it was a PR stunt. And I remember this time last year, or not this time last year, but before the last COP, EasyJet did similar. They flew, and I can't remember, I think it was something like 20% or something on sustainable aviation fuel. But hydrogen is something that they say is going to be the fuel, but it has to be on big planes because of the volume of space that hydrogen has to take. But all these technologies doesn't actually address the other greenhouse gases that aviation releases.
Yeah.
So it's not just carbon; it's also the greenhouse gases as well that the planet is facing, and we're all facing.
If nobody's asking anything, maybe I'll just bring up another concept which people can think about, and that's a paradox called Jevons paradox, which is worth thinking about, because that was actually when coal was being mined to actually fuel the Industrial Revolution. They noticed that a new steam engine had come out, which was going to reduce. It's so much more efficient. It was going to reduce the demand for coal. Of course, what actually happened was the demand for coal massively increased, and that tends to be what happens when you have an improvement in efficiency. We're hoping that our renewable energy sources and our different approaches to technology are going to solve the problem. But in fact, what quite often happens is they give an extra boost to the problem that we already have. So this is why renewable energy, as it's called, is vital, but actually without a change in society, so we reduce our demands, it's probably actually making things worse, because it's enabling us to carry on growing and imagining we can carry on regardless. I saw a question. Who's that? What was that?
It's in there from Sharon, and it says, I'm in the process of responding to a planning application and wonder if you have any response to the description of poor performing green belt.
Interesting one. Poor performing green. Yes. Well, I mean, if it's poor performing, then maybe its performance should be increased, not that it should be built on. Green belts are originally there to stop urban sprawl into the countryside. But they weren't actually that, which makes it slightly awkward, because they were there to stop something, not to be something. Maybe the new reason for green belt is to actually give them a positive reason for existing, and therefore, if they're performing poorly, improve their performance. There are all sorts of other arguments you could bring into place there. They're green belts and other green space ring the larger towns and cities. And maybe their use should be to actually give people a green lung, so people can get into the countryside and into green space far more easily. So we shouldn't be planning on building over them. We should actually be planning on improving them and expanding them.
Okay, we got a question from Jane.
Yes, thank you. Thanks, Sally. Thank you very much, Tony. Every question I thought about asking, you actually dealt with during your presentation. That was absolutely fascinating. The Horsham map you showed, is that run by Horsham Borough Council? Has this all come about because of the Borough Council, or did Wildlife Trust or whoever approach them?
That's a very interesting example. Yes, quite a long time ago, Horsham is called District Council there, got in touch with the Sussex Wildlife Trust. So the initiative originally came from them, but it's quite a long time ago. The leader at the time read a conservation strategy that we happened to have written within the Wildlife Trust and said he liked it. He wanted to do that in Horsham. So that was the birth of a partnership which then formed. So it's a partnership between Horsham District Council and the Sussex Wildlife Trust called Wilder Horsham. So yes, it was a kind of meeting of minds, really. And I think Horsham is not exceptional. I think there's quite a few places that are doing this and looking for partnerships so that we can actually develop a nature recovery network. It's actually becoming part of planning requirements to develop a nature recovery strategy. So this is actually quite. I think Horsham were quite in advance of a lot of other places, but actually this is now becoming quite normal to have to develop a nature recovery strategy based on the idea of these nature recovery network maps.
So if that's the case, how is it that so often, if planning is actually denied, they go to appeal and more often than not get it?
Oh, I know, yes. Yeah, it was ever thus as well, wasn't it? You can have the best district council in the world and then somebody appeals and it goes to the Secretary of State and they overrun it.
But if everybody's got a strategy or should have a strategy by law, then that wouldn't that help stop the planning, the unhelpful planning?
I think it should be used as a strong argument. Nothing's ever certain, but actually I think one thing that should have happened is that these new nature recovery strategies, which are actually coordinated at a county level, but often implemented, it seems, at a district level. So you'll have to see how it works in your area.
Right.
But they are a planning consideration, and actually, I think it does form part of the argument that planning should be delivering these nature recovery strategies as much as anything else, probably more so, because that's where the control is.
Right. Fascinating. Thank you very much.
Give it a go.
Yes.
Tony, does the Environment Bill help at all?
That is part of the Environment Act. I think it's now an act. It's part of the Environment Act. Yes, the whole idea of some of these things, probably another subject, and have got some concerns about them. But the idea of net biodiversity gain, how that's implemented, the idea of nature recovery strategies and the networks, how that's implemented, that is in the Environment Act. And to be fair, that does seem to have increased the likelihood of us being able to deliver positive results in the natural environment.
Yeah, someone's just, Vivian just said, West and East Sussex County Councils are working on coordinating the local nature recovery strategies. I know when I was invited to a meeting at Reigate and Banstead Council recently to try and pass on some ideas about how they could develop an action plan on climate change. So yes, every council is looking at it, and some are ahead of their times and some are now playing catch up. But yeah, definitely, it seems to be happening in our local area. But yes, I totally take Jane's point, is that you would like to see more emphasis when it comes to the planning of housing and if it goes to appeal.
Yeah, and I think actually it's a common issue that local authorities have been as good as they can be sometimes, even with past planning matters, and then it goes to appeal, and a weak government, is that the right word? I mean, essentially it's not backing up its local authorities in the delivery of its policies. So that's, I think, is a big weakness. We often blame the local authorities, and to be honest, sometimes they could do better. But actually, quite often, it's because they don't want to be to lose an appeal, which can be highly expensive for them and therefore for us. So I can see their problem.
Do you think these local landowners that you mentioned in your presentation, do you think they will achieve their aim in linking up their lands, or do you think there is real, like a recipe for other areas to follow with these landowners?
Yes, I think it's a really good initiative. I'm really positive about it because it's landowner led, and actually it's fairly flexible. So there's not a kind of legal requirement for you to do something, but they have morally committed to at least achieve something. So it's not, wall to wall rewilding or anything. It probably very little of it will be rewilding, but they're all committed to do something to enhance that network. And actually, talking to the people involved, that they are sincere. The vast majority of these landowners, they want to look for ways of delivering nature gain, and the opportunities are starting to be there, and they're starting to get their own impetus. I mean, the wheel to waves, obviously, I would say this, wouldn't I, is one of the best in the country, But actually, I think there are others in other parts. There's one in East Anglia, in Wild East Anglia, I think it's called. There's one down the Pennines. So there's all sorts of places coming together to try to achieve something. So yes, I think these sorts of things need supporting. And what actually needs to happen is we need these things to be viable options for landowners to consider. So we need the policies behind there. We need the government to actually have the policies to enable them to happen when landowners want them to happen. You know, there needs to be the appropriate financial methods to make these nature gain approaches work.
It's almost a balance, isn't it?
Yeah.
Will to ways joins up not only landowners but also green spaces and community groups, even though, and so we can all do a bit in the garden, really, can't we?
Absolutely. Yeah, but, absolutely.
I think
that's the nice message about ecological networks, is sometimes we see our gardens as very isolated and, you know, what little can we do? But if you see them as a point on a network, then it all starts to become much more engaging. And what we're finding is, far more than we realized in the past, is that species find these points. Even ones we thought didn't colonize very well. There are butterfly banks in the middle of Brighton where 12 or 13 species of butterfly have just appeared that we didn't think would happen that quickly. So yes, build it and they will come is quite a nice thought.
Absolutely. And I mean, just very quickly, because we're running out of time here, you know, the argument you get is, why should we bother when you've got China and India pumping out, you know, lots and lots of pollution? Perhaps that's a different subject for another night, but it is one of the arguments.
Yeah, I think it's looking at it from the perspective of it all being a kind of sacrifice we don't want to make. If you look at a different perspective, the world is changing. It's going to change massively. We need to get in position to be in a good place for that new world. And trying to hang on to the past by pretending that if we don't do it, other people will, is just not helpful. You could argue about China. Yes, it's producing more coal-fueled power stations than anywhere else, but it's also vastly in the lead when it comes to renewable energy.
Yes.
They're producing more solar panels than anybody else. So yeah, they're playing both games, aren't they? They're getting in position for the new world with all the renewable energy, but they're still hanging on to their coal-fired power stations. But I think rather than seeing it as a sacrifice that we want to keep all these jolly things, actually the world we're leaving had lots of problems. The world we could be moving into could be far better.
It could be far better. It could be. You're absolutely right. And I think on that note, I'm going to say, Tony, thank you so much for joining us this evening. It has been really informative, but in a way that I can understand. So I really appreciate that. And just to say, we are CAGNY, we are the umbrella group for Sussex, Surrey and Kent, we aviation and the environment together. And we are a registered climate action group with Friends of the Earth. And we have to thank Friends of the Earth, otherwise these sessions wouldn't take place as time is ticking. So tomorrow evening we have Steve Clark, 7 o'clock. You can get the links, etc. on our website, www.cagny.org. And all I have to say is thank you ever so much for everyone attending this evening. I hope to see you again. This event obviously has been recorded. It will go onto our YouTube channel in due course. And if you want to know any more about CAGNY, please go to our website or contact us. Tony, thank you. And good evening.
I should say goodbye and thank you for inviting me.
Thank you very much, both of you.
Thank you.
Thank you.
Bye-bye.
Bye.
Bye.
Right, that's one computer gone. I shall say goodbye from the other computer now. Bye.
Bye.